Okay, everyone, thanks. I did make it over the divide. Usually I end up going north of Bozeman, east of Bozeman, and don't come over the divide very much. I'm going to talk a little bit about some of our climate change research and the implications for Montana agriculture. My co-authors, myself, Fabian Manalid, Irena Grimberg, Sue Ishak, Selena Ahmed, Zach Miller, who's the director of the Ag Experiment Station in Corvallis, and Ellis Coulter, who's a sociologist. So I'll talk a little bit about climate change effects on agriculture. I'll mostly stick to one project. If you guys have other questions, feel free to ask me in the question part. And then I'll move on and I'll talk a little bit about Montana State University Extension and some surveys that we've done across the state on people's perceptions of climate change. So the climate's changing. I think we already know that. And most of these first few slides I'll just zip through. So our temperature change, we know from relative to 1900 to 1960, we're a couple degrees warmer in pretty much all parts of the state. We have our examples. We know Glacier National Park, the reduction in permanent snowfields and glaciers from 32 to 2005. And then something that Nick mentioned was the precipitation change relative to the 1900 to 1960 period. And it's actually interesting, in the western part of the state, there's this decrease, and that makes it to about the edge of the Golden Triangle. Who knows here? Does anyone know what the Golden Triangle is here? Everyone? Anyone? Okay, I'm just wondering who I'm talking to. I'll come back to the Golden Triangle in a minute. So the eastern part of the state, Montana is an enormous state. Sometimes I drive out to Scobie and I'm like, how can this still be the same state? Big part of the state. So out towards Scobie in the eastern part, there's actually been some increase in precipitation. And there's an interesting agricultural feedback that goes along with that. And there'll be more that comes out on that in the next few years. But it has to do with the reduction of what we call wheat fallow. So the typical cropping system in Montana, we have wheat one year, the next year we left it fallow, and usually since about 1950, we've kept the slate clean with herbicides, so no weeds. And that has a climate feedback. So the climate will continue to change. I think we've heard that from the other speakers. And we know that depending on what we do in the future, that our emissions, what our rate of emissions will be is how much impact it will have on the climate. But basically we can expect this. We can expect there'll be, under a lower scenario, we'll have 13 to 16 days of hotter, drier weather in this, and then under high emissions, many more, 25 to 28, so hot days. And where does that make a difference? If you're a wheat plant, you have to think about what you experience in Montana. So you're a wheat plant, and you're sitting in the field. 2-3 weeks ago, it was freezing, it snowed. And then this week, what happened? It's nearly 100 degrees and you can barely control your physiology. You're losing water, it's flying out of your cells. You're doing all you can to really grow and produce grain. And then there's another portion, and Nick didn't mention this, but so we have a lower emission scenario, higher emission scenario again, and the number of days of heavy precipitation. And that was likely to increase, and I think we can generally think of that. But what does that mean for agriculture? And that's what I always come back to. What does it mean for agriculture? Big supercell thunderstorms in late June, July, and early August in Montana. What does that do? That destroys millions of dollars worth of wheat, barley, and other things in the field. Heavy lodging, hail damage that shatters heads, puts the grain on the ground. You get feedbacks with disease cycles, such as the most prevalent disease in the Golden Triangle in those areas, wheat streak mosaic virus. The more hail you get, the more damage you get, the more you're calling your crop adjuster, the more insurance money's getting paid out. So it comes into thinking about the money. So what does this mean for Montana agriculture? And we'll go through this a little bit. This is Fort Ellis experimental research site. It was the first military fort in the Gallatin Valley, 1870 to 1886, I think. We actually find horseshoes and all kinds of things that come out of the ground out of this place when we're tilling. So we've got a 5-year cropping system study that's going on here. And so Fort Ellis itself, I think Dr. Running mentioned, 12, 14 inches in Missoula? And that's about the same. If you think of Havre, which is kind of one end of the Golden Triangle, we're going to say 10 to 14 inches of precipitation a year. So considerably drier than this site. This site's at the west or the far eastern end of the Gallatin Valley, and it kind of sits in a catcher's mitt, so it gets quite a bit more moisture. So this is a high moisture scenario for a Montana cropping system. 17 inches of precipitation a year. We've asked a couple questions. How will climate change impact crops and weed interactions? So we've heard a couple speakers mention, there'll be more CO2 in the atmosphere. It'll be like fertilizer for plants, right? Yeah, but it'll be for fertilizer for weeds too. And so farmers have to think about, what are the plant-plant interactions, the crop and weed interactions going to change? And then does climate change impact conventional versus organic farming systems equally? Organic farmers, they're kind of fighting with one hand behind their back against weeds all the time. They don't really, until you're a farmer, you don't understand glyphosate. Glyphosate is Roundup made by Monsanto. You can curse it as much as anyone wants to curse it, or some people would, but really it's an important tool, and herbicides are important tools for farmers. And so we have to give respect to these organic farmers who are fighting with one hand behind their back against weeds. So the 5-year rotation looks like this. So it's a 5-year rotation that starts out in safflower, which for the first year, and which is sown with sweet clover in between the rows, double sown. Then the second year, after you harvest the safflower, the sweet clover grows. It's a biennial plant. Nitrogen fixer, so it'll put nitrogen back in the soil, reduce our need for nitrate fertilizers. Then the third year is a winter wheat crop. Fourth year is a high-value lentil crop. In Montana, where I think the third largest producer of pulses in the United States, it's a big, important commodity for Montana farmers, the pulse crops, peas, lentils, chickpeas. And then the fifth year is back to a winter wheat rotation. So this is a little bit unorthodox. It's a research project trying to improve Montana cropping systems. And we're looking at it across 3 different types of farming systems. An organic system that's reliant on tillage for weed control. And this is a typical organic system in the state of Montana. If you're out on John Tester's farm or you're up around Big Sandy, these guys are really reliant on tillage for weed control. Who knows what happens in Big Sandy? Too, the wind blows. So you have big wind erosion problems. So thinking about soil health in these organic systems is important. So we've tried to come up with a way to reduce tillage. And we've done that by using an organic system with grazing. So introducing sheep grazing into the system where you reduce tillage, reduce soil erosion, add some economic output by having sheep on there. And then we compare that finally to a chemical no-till system, which is kind of wheat fallow system where I talked about before, where you grow wheat one year, the next year it goes into fallow, and you keep the weeds away with chemicals. So this chem no-till uses a lot of herbicide, uses some nitrate fertilizers. So the organic graze, I guess I should mention, is not quite a no-till, but it's 36 of 60 months of this system has been no grazing, or no-tilling, excuse me. So we're interested in increased temperature and what increased temperature has on the effect of these cropping systems. And so we utilize these things called open-top chambers, and we put these out. And basically the convective heat raises it a couple degrees. This system was first kind of used in Arctic systems to understand how increased temperatures affected Arctic ecosystems. And so we've been using this in wheat cropping systems in Montana. And sometimes they look like this in the winter. They tend to melt out earlier. We have good evidence that we're raising the temperature about 2 degrees Celsius, 3.6 degrees Fahrenheit, I think is what it is. And then we have another treatment, because what's the important treatment is how much the moisture changes. So then we've also increased temperature and reduced moisture by putting these slats over the top. It's called a Rainout Shelter. And we're blocking about 50% of the area, and then looking at these small scale plots. This is what it looks like towards the end of the season. The grain's starting to mature. You can see there's more weeds definitely coming out of the open top chamber there. So I'll first concentrate on the interactions of weeds and climate. So we looked at this in 3 climates. So green is the current climate, yellow is the warmer climate, and the red is the hotter and drier climate. And the 3 systems are at the bottom there. And it's the no-till chem, the organic graze, and the organic tillage. And biomass of the weeds is on the y-axis. So what happens when you get hotter and drier, or hotter and then hotter and drier? In the chem no-till, where the herbicides still work, and we fortunately don't have to worry about too much herbicide resistance in these areas, you can see as you go up in both the organic graze system, which tends to have a whole lot of weeds in it, and the organic tillage system, you get a little bit of increase in weed biomass between each one. So as we're thinking of a hotter and drier climate, farmers might have to think we're going to have more weed competition and worry about reduced yields, and I'll come back to that. Establishment of weeds in the field. So cheatgrass, I should mention, Cheatgrass bromus tectorum. It's a weed as old as agriculture. It came from the Fertile Crescent. When you have a warmer and drier climate, the red there, you can see that there's better establishment in the late fall seasons of bromus tectorum, of cheatgrass. So we're going to get denser stands of cheatgrass, which is really the #1 weed, especially in winter wheat cropping systems. And so for the organic farmers who are thinking about this, especially with no herbicide options, it becomes a bit daunting. You think you're going to have more weeds. We also end up with actually larger seed production in the hotter and drier climate of bromus tectorum too. And so I'll switch and think, let's not think so much about the change associated with temperature, but let's think about CO2. And someone mentioned before, CO2 will be a fertilizer for plants. We'll have more CO2 in the atmosphere. Yes, that's true, but in our trials from the greenhouse and climate chambers, we have in bromus tectorum produces more biomass as CO2 increases. So it's a trade-off. The wheat may perform better depending on conditions, but the cheatgrass will certainly perform better. And then there's other evidence that cheatgrass reproductive biomass, so the number of seeds produced, actually also goes up as you go up over 400 parts per million of CO2 in the atmosphere. So we're going to think more weeds, and maybe a mid to long-term shift in weed communities. And so we have to think about the wheat crop interaction. But then if we think just of wheat by itself and just the yield, taking it out all other extraneous factors, we've kind of looked at this, and then the current climate, this is the first year of data, we end up with these normal-looking little plants in the current climate. The hotter actually is if you have sufficient moisture, the plant starts growing earlier in the year, and the plant grows a little larger. As soon as that moisture deficit comes online, which is about this time of year, you start to really draw down soil moisture, the plant doesn't grow as well, and you end up with a smaller plant. And we actually see that in our yield. So on the y-axis, the vertical axis here, we have the wheat yield in tons per hectare. And you can see in the organic tillage and the organic graze system, we'll put the organic graze over on the side. It's kind of a new system. We're still experimenting with it. The organic tilled system is very interesting. There's no differences under any of the climate scenarios. But if you look under the no-till chem and you look at the current climate, then you follow it to the yellow line and then to the red box below, the yields decrease as we get hotter and drier. And that's based. So we're starting to figure out that climate change will impact crops and weeds. We'll get reduced yields and increased weed growth. But the climate impact on conventional or organic systems may not actually be may not be the same And there's some evidence to suggest that organic systems might be a little bit more resilient. And we're working on some of this research a little bit more, especially, but tillage seems to play a large role in that. But when we have to think now, what are our opportunities, and think of who the stakeholders we are. As myself, as a ag researcher in Montana, I'm really working for the citizens of Montana and the state of Montana, and we have to think about our stakeholders. And so we're thinking about these our farmers and ranchers across the state and how this interacts. And so this diagram comes from the IPCC report from, I think this one's from the 2007, and I've been talking about the blue box down to the green box, which is the climate change impacts and vulnerabilities. But if we think about the processes and drivers and how those all interact with socioeconomic development and the whole process, we think about attitudes, concerns, and beliefs. And so I'm going to come back to this, talking about our attitudes, concerns, and beliefs. So I mentioned before that most of the time I go to the north central part of the state or the northeastern part of the state. That's really where the wheat cropping systems are in this part of the state. And we've done some surveys asking farmers and consultants, insurance adjusters, things like that. We've asked them a few questions about their perceptions of agriculture. One, do stakeholders acknowledge climate change exists? Two, is climate change perceived as an imminent problem? Three, are humans capable to mitigate the impacts of climate change? And then four, what are the causes of climate change? And so you can summarize these as attitude questions. And so question one, what describes your attitude towards climate change? The climate has not changed. Two, I'm not alarmed. Three, I'm somehow alarmed. Or four, I'm very alarmed. The seriousness of the problem. Do you think that changes in climate will be a serious issue? Never, only in the present, in the near future, or always? And then the capability. What capabilities do we have? Do you think people have the capability to reduce the impacts of climate change? So the climate has not changed. Two, no, not. Three is not sure, and four is yes. We have the capability to reduce impacts. And then then the next one is the cause. What is the main cause of climate change? One, the climate has not changed. Two, it's man-made activities. Three, it's natural terrestrial cycles and catastrophes. Four, extraterrestrial natural phenomena, sunspots, meteorites. Five, non-physical causes such as God. And six is other. So, we also asked what went along with that, where we were, the location, their affiliations, their political affiliations, age, income, another political view. Actually, affiliations there was what type of job they were performing and why they were at these events. Political view, gender, race, and ethnicity. So here's where we took the samples from across the state. So the Golden Triangle, we had 66 respondents. Up on the High Line, we had 110. The Judith Basin, 36. Around the headwaters, 123. And in the southeast portion of the state, where really no one is, 21. I think Malta can fight with Baker about who has some more people. So, political views versus perception. So here's this sort of, I call it a windrose diagram. I'm not sure what the true correct name is. But one at the top is you're a liberal. And as you come around the circle, 2, 3, 4, 5, 6, 7, you'll end up at the most conservative. And then rating those answers on the questions I just read, 0, 1, 2, 3, 4. So, goes around like that, goes up like that. So the first question, how concerned are you about the impact of climate change on Montana's agricultural production? I thought this is interesting. No difference. Can perceive the exact same way. Because Montana farmers know that climate's changing. If you ask John Tester, he'll say, yeah, we plant and harvest 3-4 weeks earlier than we did when I was a kid. You can talk to any farmer. That's just one example. So here's where it gets a little more interesting. The next question was, how serious do you think climate change will become in the future? So basically still everyone thinks it will become a pretty serious problem. 1 is no, or 0 is no, it won't be serious, and 4 will be most serious. You can see there starts to be a little breakaway at the most conservative, politically leaning people. And then the next question was, do you think people have the ability to mitigate climate change? And you can see with people who are a little bit more liberal, we think we have the ability, or there is the ability. And then as you move towards 6 and 7, but I would still note, out on a scale of 1 to 7, the people who are voting 6 on political views actually think we have the ability to mitigate climate change. And then here's where the gap starts to come in, and that's this one: political views versus the causes of climate change. And so the blue bar is it's man-made, red bar other causes, and the green bar not changing at all. I'll just let that one speak for itself. So do Montana agricultural stakeholders acknowledge climate change? You bet. Between 89 and 95% of Montana agricultural stakeholders acknowledge climate change. Is climate change perceived as an imminent problem? Yes, 83% of Montana agricultural stakeholders think it's a serious problem. In now or in the future. Are the humans capable to mitigate impacts of climate change? 46% of Montana's agricultural stakeholders think we can mitigate the effects of climate change. And then finally, what are the main causes? Only 36% of Montana stakeholders attribute climate change to human activities. So there's where we start to see our divide. And so when I was talking about this with some of my colleagues, I was like, yeah, where do we go? What do we do from here? And basically, what we came up with was we need to depoliticize the causes of climate change. We all recognize it, but it has to be depoliticized in some ways. And so I'll just end on this. I'll just mention you guys can contact myself. My email's there, or Fabian Manala, who's mostly responsible for the extension in these projects. And his email address and telephone number are also there. And then a quote by Abraham Lincoln: "The dogmas of the quiet past are inadequate to the stormy present. The occasion is piled with difficulty, and we must rise to the occasion. Our case is new, so we must think new and act new." And I'll leave it at that. If anyone has any questions.